Okay, we want to find the vertex, focus, and directrix of the parabola given by the equation 6x minus 3y squared minus 12y plus 4 equals 0. Now hopefully it's clear that because the exponent of 2 is on the y, the standard form for this equation is going to have this form. The quantity y minus k squared equals 4p times the quantity x minus h. So our job is to make this equation look like this standard form. And the first step is to get anything with y squared or y in it by itself on one side of the equation. So to do that, I'm going to go ahead and move the 3y squared and the 12y to the right-hand side. And I'll get 6x plus 4 on the left-hand side equals 3y squared plus 12y. Or if we want to keep y on the left-hand side, not that it really matters, we could rewrite it like this. Okay. Now, I want to go ahead and complete the square on 3y squared plus 12y. But to do that, I need a 1 in front of the y squared. So how do I get a 1? Well, one way to do that is to factor out the 3 or divide through by 3. I prefer factoring it out, at least to start with. And if I factor out the 3, what's left is y squared plus 4y, leave some room, close the parenthesis, equals 6x plus 4. Okay, now I can complete the square on the guy inside the parentheses. And the way I do that is I take half the coefficient of the y, which is 2. Let me write that down. And then I square the 2 and add it. But I'm not really adding 2 squared, which is 4. I'm really adding 3 times 4. So I've got to add the same thing to the other side. And then y squared plus 4y plus 4 factors to be y plus 2 quantity squared. Don't forget the 3. And don't forget to simplify the right side, make it 6x plus 4 plus 12 is plus 16. Okay, now we're almost there. All I have to do is, well, first of all, get the x, get a 1 in front of the x inside parentheses by factoring out a 6. And also, at some point, I'm going to have to divide by 3 so that I have just y plus 2 quantity squared by itself on the left-hand side. Okay. Well, it really doesn't matter which order I do these things in. So I'm going to go ahead and factor out the 6, let's say. If I do that, I still have 3 times the quantity y plus 2 squared on the left side. And if I factor out the 6, what does that leave me with? Well, okay, the trick is to realize that if you factor out a number like 6 from 16, then what's left over is, inside the parentheses, is 16 divided by the number you factored out. And I'll simplify that in the next step. So that, okay, all I have to do then is divide by 3, simplify the 16/6, and it will be in standard form. So I'll end up with y plus 2 quantity squared equals 2 times the quantity x plus, well, 16/6 reduces to 8/3. So that the vertex, okay, careful here, the x-coordinate of the vertex h is going to be negative 8/3. And the y-coordinate is going to be negative 2. Okay, so now we need to come up with the focus and directrix. Before we do that, I want you to realize that, well, okay, 4p is equal to 2, which means p is equal to 2/4 or 1/2. And because of the exponent of 2 being attached to the quantity involving y, we know this is a parabola that opens sideways. And because p is 1/2, we know it opens to the right. If p were negative 1/2, it would open to the left. So a quick sketch gives you a picture that looks something like this. It's not going to be to scale or anything, but gives you an idea of what your parabola looks like. The focus will be in here somewhere, the vertex here, and the directrix is a vertical line in this case when the parabola opens sideways. So that means if we want to get to the focus point, all we have to do is go, in this case, a true distance of p, because p is positive. We go a distance of p to the right of the vertex to get to the focus. Okay. That means all we have to do is take the coordinates of the vertex, -8/3, -2, and because we're going horizontally to the right, I can add p to the first coordinate of the vertex to get over from the vertex to the focus. So I get -8/3 plus 1/2. Well, -8/3 is really -16/6, and 1/2 is 3/6. So the focus point has first coordinate -13/6, and the second coordinate doesn't change from the second coordinate of the vertex. It's -2. So, okay, there's your focus point. And your directrix is going to have, well, it's a vertical line. So vertical lines always have the equation x equals a constant. To find out what that constant is, all you have to do is set x equal to, well, start with the first coordinate of the vertex, which was -8/3, and go to the left p units. So that distance is supposed to be p units as well, directly to the left of the vertex. And we know that that's 1/2, so that means I need to subtract 1/2 to go to the left and get out to the directrix. Well, okay, so that's going to be -16/6 minus 3/6 this time, which takes me to -19/6. So set x equal to -19/6, and you have the equation of your directrix. So the directrix is x equals -19/6. The focus is -13/6, comma, -2. And the vertex is -8/3, -2.